Hi guys, welcome to Math with Mr. Husky. Today we're in section 6-3, Similar Figures and Scale Drawing. Similar figures have the same shape but different sizes. They also have equal corresponding angles and proportional corresponding sides. So if we look at these two triangles, we have triangle ABC and triangle DEF. We look, they both have the top angle of 50. Those are the corresponding angles, they're the same. Same as 60 and 60 and 70 and 70. Now to show that we have corresponding sides are proportional, let's do that. Let's take side AC, which has 10, and side AB, which has 9. And we say that has to be proportional and equal to the corresponding side to 10 is 20. The corresponding side to 9 is 18. And if we look, we can multiply these. We can say 9 times 20 is 180. And 10 times 18 is 180. So since these two numbers are the same, we can say that yes, those two ratios form a proportion. So the sides of the triangles are proportional. Down here, we have two parallelograms. Parallelogram ABC is similar to EFG. This little sign in here means similar. So that means that their sides are proportional, and we need to find the missing side of x. So let's set up a ratio with our first parallelogram. We take 16, put it on the top, and our missing side of x, put on the bottom. We'll say equals, we need to make a proportion. So 16 corresponds with side 24, so we have 16 and 24 correspond. They need to go in the same position, so both on the top of their ratios. X and 18 correspond, so x and 18 need to go on the same side, so the bottom. Now if we have to solve for this now, we'd find it. So 16 times, if I do 16 times 18, I get 288, and that's equal to 24 times x, which is 24x. I then solve for x, dividing by 24. 288 divided by 24 gets me 12. So x equals 12. The next way we have to do this is we're going to use indirect measurement. Indirect measurement is what we use when we can't actually measure a distance. We're going to use proportions and draw similar figures to solve it. So if a tree casts a shadow 10 feet long, so I'm going to draw a tree in here, my wonderful artistic ability. It's my wonderful Christmas tree, and it's going to cast a shadow 10 feet long. So I'm going to put 10 feet. A 5-foot tall student, we all know that's not going to be Sam though, is standing there. And he casts a shadow, so first off he's 5 feet, casts a shadow that is 4 feet long. What can we make with these? We can make similar triangles. There's one triangle, there's the other. So we have 10, we're looking for the height of the tree, so x, and then 4 and 5. If I make a proportion with these, I'm going to take my vertical side, or my height, which is x, and put it over my shadow, which is 10. That's equal to, since I use height on the top, I need to use height on the top again, so I say 5 over 4. And then I solve this. I say 10 times 5 is 50. And I say x times 4 equals 4x. I divide by 4 to both of them, and I get x equals 12.5. But I can't forget that I need a label. I look back, everything's in feet, so 12.5 feet. The last problem we have is dealing with scales and scale drawings, which is going to be helpful with your blueprints. So the scale on a map is 1 inch is 40 miles. I'm going to stop right there, and I'm going to say I need to make a proportion out of this somehow. So I'm going to take 1 inch to 40 miles and make a ratio. I'm going to put inches on top and miles on bottom. Put my equal sign and start another ratio. About how far is it if you measure 1.5 inches on the map? So since I have inches on the top of my first ratio, I need inches on the top of my second ratio. And I'm looking for an actual distance in miles, but I don't know it, so I'm going to say x. So I'm going to say cross multiply. 40 times 1.5 is going to get me 60 equals 1x, because I cross multiplied and got that. So my answer is 60 miles. When we do ratios on blueprints, you guys will have to create your own 1 inch 40 miles, something for your actual trebuchets. So we can go over that the next few days in class. That's all for today, guys. Don't forget to subscribe.